Okay, we'll make a start on part 2 of the SAC from Thursday, and the next couple of questions, questions 7 to 13, refer to this graph here. So what we need, the information we need to pull off this straight away is its velocity time graph. Alright, and it has given us a direction here, so this direction here is going to be north, then this direction on this side of the line is going to be south. Okay, let's have a look at what they want us to find out. Question 7. Fully state the car's velocity 4 seconds after starting its motion. Okay, 4 seconds, back to the graph. Alright, 4 seconds is here. We draw a line up from 4 seconds and it intercepts here. We go across, and remember I warned you about this graph, it's just a little bit sloppy. So 6 is up here. So halfway between 4 and 6 is 5. 5 metres per second north. So over 4 seconds it is travelling at 5 metres per second north. Okay, question 8. Fully state the car's velocity 10 seconds after starting its motion. Alright, velocity 10 seconds. 10 seconds is halfway between 8 and 12. Up we go to here and across, and this is 10 metres per second north. So, 10 metres per second north. Alright. Question 9. Fully state the car's acceleration 18 seconds after starting its motion. Alright, so on our velocity time graph, acceleration is the gradient. So 18 seconds is this point here. So we're looking at this gradient here. Now this gradient's consistent all the way along here, so I'm going to take the whole lot. So look at this. Our gradient is going to be rise over run. Rise over run. Let's get some numbers here. Well, the rise is 10 and the run is 20 minus 16, so the run here is 4. So the rise 10, run 4. Now the other thing to remember here is this is a positive gradient, this is the opposite, so it's a negative gradient. So in fact we're losing 10. Now rise over run. So 10 divided by 4 is 2.5. Minus 10 divided by 4 is minus 2.5. Its acceleration, so that is metres per second squared. Question number 10. What distance does the car travel in the first 20 seconds of its motion? Distance, first 20 seconds. Okay, back to our graph. In the first 20 seconds, this is the first 20 seconds of its motion, from here to here. The distance is the area under a velocity time graph is the distance. So what we need to do is work out the area of this shape here. Now we can break this up into 3 shapes. There's one triangle here, and another triangle here, and a rectangle here. So what we'll do, we'll go ahead and work this out. So the area of a triangle is half base times height. The base is 8. The height is 10. So for our first triangle, half base times height, half times by, what did I say? 8 times 10. Half 8 times 10. Half times 8 is 4. 4 times 10 is 40. That's in metres. Our second triangle here, the base is 4 and the height is 10. So half base times height, half 4 times 10, half times 4 is 2, 2 tens is 20. Okay, so the area of that triangle is 20. Now we just have our rectangular portion of the shape to solve. Okay, the distance here is 16 minus 8, so that's 8 from there to there, and the height is 10. So a rectangle, base times height, 8 times 10, that's 80. Alright, so now we've got the area under those 3 different sections, add them all together. So we've got the total area, and therefore the total distance is 80 plus 20, which is 100, plus 40, it's 140. 140 metres. Okay. Distance, not displacement. So it's just a scalar, we don't need a direction, 140 metres. Okay. Going over to question 11. What is the car's final displacement from its starting point? Now, when you look at this graph, it doesn't return to the starting point. This is not displacement over time graph, it's a velocity over time graph. So, we're already halfway there. We've already calculated this distance here. This is how far it's travelled in the north direction. This area here is how far it's travelled in the southerly direction. So we just need to work out the difference between the two. So again, we're just going to go through exactly the same process. Let's break these up into two triangles and a rectangle. The base here is 4 and the height is 10. So half base times by height, half times by 4 times by 10. Half times 4 is 2, 2 tens are 20 metres, and we'll set up for our other triangle, half base times height. Okay, the base here is 4, and the height here is 10. 4 times 10, half times by 4 times by 10. Half times 4 is 2, 2 tens are 20. And that's metres. And the last bit of the area is a rectangle, so it's just base times height. The base here is the difference between 24 and 36, which is 12, and the height here is 10. So the base is 12, the height's 10, that is 120 metres. Okay, adding them up together, we've got 120 plus 20, that's 140 plus 20 equals 160 metres. Alright, so we know from our previous question that it travelled 140 metres north, and then it's turned around and it's travelled 160 metres south, so that little bit further there. So the difference is 20 metres south. Alternatively, if you had minus 20 metres north, I would have been happy with that as well. Alright, one more before we call it quits on this one. Question 12, what distance does the car travel between 24 seconds and 36 seconds? Alright, I've already done this. The distance between 24 and 36, so the area under the graph between the 24 second mark and the 36 second mark. Area under the graph between 24 and 36, look at that, I've chosen a nice easy shape for you, a rectangle. So, again, 12 seconds times by 10, 12 tens, 120. And this is just exactly the same here. So, base times height is 12 seconds times by 10 metres per second is 120 metres, distance metres. Alright, great, that's the end of part 2.